All right, a second order maximum is produced 1 centimeter from the central when the wavelength is 450 nanometers on a double slit. If the screen is 30 centimeters from the double slit, what is the slit separation? So in other words, it's asking for that D value. All right, I'm going to draw a quick little picture, just kind of visualize this again. So here we have the waves coming in, and the wavelength, which is the distance between one peak to the next peak, is 450 nanometers. That is my wavelength. And then passes by some slit separation, which I don't know in this case, which is my D value, which is the distance from here to here. And it produces that pattern, so it has a bright spot right in the center. We'll have a first order max here, and then it will also have a second order max up here. So this is n equals 1, this is n equals 2, and this is the one we're dealing with, the n equals 2 type scenario. And it says that is 1 centimeter from the central bright spot. So that is its x value. So the x value in this case is going to be the distance all the way up. And that's going to be 1.0 centimeters. And it says the screen, which is known as my length, L, is 30 centimeters away. All right, so I have an X, I have an L, I have a lambda. I want to solve for D. I'm going to use the small angle approximation equation, which then says lambda is equal to D times X divided by N over L. Sorry, NL. Distance, X, the distance between the bright spots, N, the number, in this case N equals 2, because it's talking about second order bright spot, and L is the length between the slits and the screen. So if I want to solve for that D value, I'm going to rearrange, solve for D. Lambda times N times L divided by our X. So in other words, 450 nanometers times 10 to the negative 9. N equals 2. Our length is 30 centimeters, 0.30 meters. If you notice, everything is here in meters. So I even converted nanometers to meters. And then X being 1 centimeter, which is 0.01 meters. So if I go ahead and solve for the distance, I'm left with 450 times 10 to the negative 9 times 2 times 0.3 divided by 0.01 gives me 2.7 times 10 to the negative 5. Perfect. So 2 sig digs. So that'd be the distance between the two bright spots.